Hi guys, I welcome you all to my YouTube channel. Today we want to show that 3 into bracket of 2 raised to power n plus 1 plus 2 raised to power n all divided by 2 raised to power n plus 1 minus 2 raised to power n plus 2 equals to 4. We want to show that the left hand side of this equation equals to the right hand side. But before we get started, if you are new to my YouTube channel, do well to subscribe in order for you to be aware of when I drop a new video. Let's get started. So we go by writing the solution. Solution to the equation. From the left hand side of the equation, we have 3 into bracket of 2 raised to power of n plus 1 plus 2 raised to power of n divided by 2 raised to power n plus 1 minus 2 raised to power n minus 2. We want to show that the left hand side of this equals to 4. To do that, don't forget from the basic law of indices, I mean the product law of indices. If you have a raised to power of n plus m, I can have it as a raised to power n dot a raised to power of m. So if I apply the application of this to this question, the 2 raised to power of n plus 1 can be written as 2 raised to power n dot 2 raised to power 1. We all agree to that based on the rule. So here we have 3 into bracket of 2 raised to power n dot 2 raised to power 1 plus 2 raised to power n all divided by, so for the denominator, I want to take out 2 raised to power n plus n minus 2. Taking this one out, we create a bracket, then we write 2 raised to power of n plus 1 dot. So we are going to write 2 raised to power n minus 2 but in negative form. 2 raised to power of minus into bracket of n minus 2 minus 1. So this assumption is telling you that if you open the bracket at the denominator by 2 raised to power of n minus 2, so you get this thing back. The denominator can be written as 2 raised to power of n. Since 2 raised to power of n is common, let me take out 2 raised to power n. In bracket 3.2 raised to power 1 plus 1. So we have 2 raised to power of n that is common at the numerator divided by, here is 2 raised to power of n dot 2 raised to power of minus 2. So we are still back to the product law of indices. Bracket 2 raised to power of, don't forget that we have the same base, I can add the power together, plus 1. But when you're adding this power together, so remember we have negative here. So this negative, we multiply that positive, then we are going to have negative again. We have negative, create the bracket, n minus 2, then minus 1. We are progressing. Now at this stage, this 2 raised to power n will nullify 2 raised to power of n. Then you have 3.2 here, it means 6. Then 6 plus 1, that is 7, all divided by This 2 raised to power n, 2 raised to the power of minus 2, I can have it as 2 raised to the power of 2. That is negative power law of indices. That is, we have something like a raised to the power of minus n. It can be written as a raised to the power 1 divided by a raised to the power of n. So into bracket of 2 raised to the power of, let's open the bracket and do necessary simplification. We have 2 plus 1 minus multiplied by this, that is minus n, minus times minus 2, that is plus 2, minus 1. So minus n and plus n will cancel. So here at the numerator, I can have it as 7 divided by 1 divided by 2 raised to the power 2. It means 2 times 2, that is 4. Bracket. So here we have 1 and 2 left. Then 1 plus 2, that is 3. We have 2 raised to the power of 3 minus 1. So you believe that this can imply that 7 divided by 1 divided by 4, bracket 2 raised to the power 3 is 8, right? Then 8 minus 1, that is 7. So if 7 cancels 7, 7 here is 1. We are going to have 1 divided by 1 over 4. So by applying the reciprocal law of indices here, 4 will multiply 1. Then we are going to have 4, which is the required proving. So which shows that the left hand side of this equation equals to the right hand side. If you are new to my channel, once again, try to give a thumbnail if you're enjoying this video, and subscribe to my YouTube channel in order for you to be aware of when I drop a new video. Thank you for watching. See you in the next video.